So now we've composited this together in Photoshop. We found a way that adds these up and makes them look really close to the correct final color output. But we've also established that when I turn on the real Modo-generated final color output, things they don't match up perfectly. Some of our pixel color accuracy is not perfect. I'm going to jump back over to Bridge, and you'll notice that other set of images that I've saved out. This is what those are for. These are 32-bit float EXR files. That means that all of the pixel accuracy that is rendered within Modo, all the pixel accuracy that's been calculated by Modo's rendering engine is included in these files, unlike these, which are 16-bit images. Now, 16-bit images are extremely accurate, and for the most part, they're going to be absolutely sufficient for what you do. In fact, I'll tell you, in my practice, I almost never use 32-bit images. They introduce all kinds of headaches that we won't get into. But if you're going to be doing a serious composite like this, then these 32-bit images start to make a lot of sense. But keep in mind, of course, one of these 16-bit images is 5.3 megs. One of these 32-bit images is 16.7 megs, a full 3 times more data. Just keep that in mind. You're going to drive yourself crazy with huge files if you work in 32-bit EXR all the time. So let's go to Tools, Photoshop, and load these guys into Photoshop layers as well, and we can look at these side by side. So here's the same exact image loaded up as a 32-bit file, and if I go up to my Image menu and down to my Mode, you'll see that it is a 32-bit file, whereas this other one, if I head up to Image, Mode, it is a 16-bit file. Okay, so here's my 32-bit file. I'll do the same exact thing that I did before to this. I'm just going to change each one of these to linear dodge, aka add. It would be add in After Effects. And I have to do these one at a time in Photoshop, unfortunately, but in After Effects you could do them all at once. And once I do that, the result is going to be perfect. I don't need an adjustment layer. I don't need any such thing. Because this is a 32-bit image, that means that a linear gamma space is going to be perfectly appropriate. We don't need any adjustments whatsoever to this. And if I hop back over to my other document, this is our final composite, and you'll notice that everything is pretty much identical. There are some very, very minor differences, but in fact, it may well be that the 32-bit image is more accurate than the 16-bit composite image. And this, my friends, is the secret to getting good composites if you're going to separate out all of the different layers of a Modo render. Now, whether or not it is worth it to do that is a whole nother question. And typically, in practice, I don't actually do this. I need to stress that. I don't recommend using 32-bit EXR files and saving out every different render pass of a render in order to achieve a final output, unless you absolutely have to. Because it's going to balloon the amount of space that you need on your hard drive. It's going to take up tons of RAM. It's going to be just difficult to work with in general. Also, there's a lot less that you can do with a 32-bit image in Photoshop. For example, a lot of the filters you're used to being able to use won't work in 32-bit mode. There's just a lot that you can't do when you're working in 32-bit. It kind of ties your hands. So I definitely recommend, if you're going to do this, go ahead and do your composite, make whatever adjustments you need to make to the individual layers, and then go to your image mode, change that to 16-bit. And then, yes, merge the layers when you do that. You have to, otherwise this won't look right when you composite it. And change the method to exposure and gamma, and don't really change those at all. Hit OK, and you'll end up with a 16-bit file that matches what it should if it were a final color output. But then you had that intermediate step where you could actually make changes if you needed to. And here's a really cool idea as well. I'm going to undo that and go back to my 32-bit file here. Let's say that I really want to keep that 32-bit data. I don't mind using up all the extra RAM and hard disk space. I just want to keep all that pixel accuracy, but I also want to be working in a 16-bit file, so it's a little bit easier to work with in Photoshop. Well, what I could do, actually, is just select all of this stuff and right-click it and say, Convert to Smart Object. that's going to save this essentially as a Photoshop file within my Photoshop file. So it's a completely separate entity in there, but I can always open it back up. Now, working with smart objects, especially big ones, ones that take hundreds of megabytes like this, is going to slow things down a bit, but it can be pretty cool. So check this out. I'll go up to my image menu. I'm going to change this to mode to 16-bit image, and do not merge my layers this time. And it's going to say it's changing 16 to 16-bit, but in reality, even though this image is a 16-bit image, if I open up this smart object in a new window, and I head up to my image menu, mode, it is still a 32-bit image, folks. So I've essentially embedded a 32-bit image within a 16-bit image, and you can definitely do that if you, if you are so inclined. All right, folks, have fun with that, and let's move on to something else.